In this video, we'll be discussing the job of triggers, not those triggers. Will you let me finish? The job of triggers, not those either. The trigger used in ignition systems. In the ignition system, I say we have 5 major components in the creation of spark: power, trigger, switching, secondary, and plugs. All right, plugs are really part of the secondary, but I like to separate them out. Each of these 5 components needs to be working properly in order to create the spark to ignite the air-fuel mixture in the cylinder. A trigger is really anything that determines engine position and speed for an ignition system. Information obtained through the trigger is often used in other systems as well. It does not directly control a modern ignition system. It's information for the rest of the system to control the switch. It's important to note that this video is not going into depth about any specific trigger. There are other videos that cover those, like the VR or digital sensor video. Let's start out with the simplistic idea about what a trigger really is. We're talking about triggers, so I thought I'd have a little exercise here to try and really get across the idea of what a trigger is. So what we have is kind of a Rube Goldberg device here. Of course, we're going to kick everything off with, yes, a 10mm socket. The socket is going to go down the ramp. It's going to hit the sledgehammer. The sledgehammer handle is going to fall down. It's going to hit the jack stand. The jack stand's going to release the long extension. The extension's going to swing forward, hit everyone's favorite textbook. Textbook's going to drop. When the textbook drops, it's going to hit the stand that the flex plate it's on. The flex plate's going to rotate. It's going to drop the candle onto the camp stove, light the camp stove, and ignite the spark plug. Now, let's see if this all works. The 10mm socket in that demonstration represented the trigger. It didn't directly cause the spark plug to fire. It only started the chain of events to make it happen. Any number of things could have changed in between the socket giving its input, hitting the sledgehammer, and the spark plug being fired. There could be more or less parts between the trigger and the spark. There could have been a different amount of time between the trigger and the spark. Either way, the trigger, the 10mm socket in that case, only started the event. It didn't perform the actual work needed to complete it. Once it started the event, it was done. That was it. One of the first triggers that we've used was a cam inside a distributor and a block that rubbed against it, connected to a set of points. It looks something like this. As the cam comes close to a peak, it forces the rubbing block to open the point contacts. This causes the ignition primary circuit to open and the flow of current to stop. Once it passes that peak, the rubbing block drops to its low point, allowing the point contacts to return to a closed position, again flowing current in the primary circuit. While the trigger, in this case the distributor cam and rubbing block, is directly controlling the switch, the point contacts, it doesn't have any current flowing through it. Our trigger, that is, the rubbing block and the cam. It only starts the process, like the 10mm socket did in our other example. The current flowing in the circuit is flowing through the point contacts, which is not part of the trigger, even though it's connected to it. They're 2 separate pieces of the same assembly. In a more modern version of this system, there'll be a cam and crank position sensor acting as a trigger. Their input will feed the powertrain control module, PCM, which will then decide when it wants the spark plug to fire based on various other conditions. A little diagram of what that might look like could be something like this. Okay, Not really boom, but a spark that can properly ignite the air-fuel mixture for a good burn. We have our power, our battery right here. Our trigger needs battery power to work in most cases, not all. We'll talk about that in a different video. Our PCM definitely does. Our switch will. Okay, I didn't get that far, but we're not worried about the switch just yet. The point here is our trigger is only talking to the PCM. The PCM's actually controlling the switch, and the switch is controlling the boom. We can really see the electrical relationship between the trigger and ignition in this scope capture. What we have here is a waveform taken off a car, and what we can see in that is the trigger, in this case the camshaft position sensor. That's the red trace, and the blue trace is our primary ignition voltage. And in that primary ignition voltage, we can see when the switch comes on and grounds the circuit, so when the circuit goes from a high to a low state. The time from the trigger occurring to the switch going on is about 90 milliseconds. In engine speak, there's a fair amount of time between those two. Now, we're going to throw one more piece in here. We have our spark, which is actually down there. The time between our switch coming on and our spark is only about 1.5 milliseconds. Right here, what I want to illustrate is the difference between trigger and the switch. The trigger happened a long time before the switch. The trigger, once again, was just an input to another component to give that component an idea of when to switch the circuit on and off to create the spark at the proper time. There are a couple main things I want you to take away from this. The trigger is necessary for spark. Without it, the control mechanism has no idea what stroke the engine is on or what speed it's rotating at. So no trigger, no run. Doesn't happen. Another is that when you're identifying system components and trying to determine what the trigger will never carry any current. Even a powered trigger, like a digital sensor, doesn't carry any real current, and it carries none of the current required for ignition. Last, remember the trigger doesn't typically have direct control over spark. It's an input for another controller of some type. That controller will use the input from the trigger to determine when it wants the spark to occur. And with that, we'll catch you in the next video.